Imagine standing on Earth on what seems like an ordinary day. The sky is clear, giant dinosaurs roam across forests and plains. Nothing feels unusual. Then, without warning, a mountain-sized asteroid slams into our planet with more energy than billions of nuclear bombs combined. Within minutes, the world that had existed for more than 160 million years begins to disappear forever. But what really happened during those first terrifying minutes? Today, we're traveling back 66 million years to witness, minute by minute, the beginning of the day that ended the age of the dinosaurs. For millions of years, dinosaurs ruled nearly every corner of Earth. Towering predators hunted enormous plant eaters across vast continents. Oceans were filled with giant marine reptiles, while the skies belonged to flying reptiles with wings wider than many modern airplanes. Earth was warm, rich with life, and incredibly stable. Then everything changed. The object racing toward Earth was about 7.5 miles, or roughly 12 kilometers wide. It was traveling at nearly 45,000 miles per hour. At that speed, there was no chance for anything on Earth to stop it. No warning, no escape. As the asteroid entered Earth's atmosphere, friction heated its surface until it glowed brighter than the sun. For anyone who happened to look up, the sky would have suddenly exploded with light. It would have appeared like a blazing second sun growing larger every second. Only moments later, the asteroid struck what is now the Yucatan Peninsula in Mexico. The impact lasted less than a second. But in that single instant, history changed forever. The collision released an unimaginable amount of energy. Rock beneath the surface didn't simply crack, it vaporized. Millions of tons of molten rock were blasted high into the atmosphere. A crater nearly 120 miles across began forming almost instantly. Everything within hundreds of miles of the impact disappeared. Forests, rivers, mountains, entire ecosystems, gone. The ground itself behaved like liquid. Massive waves of rock rolled across the landscape. Earthquakes far stronger than anything recorded in human history raced outward in every direction. Animals closest to the impact never had time to react. They didn't run. They didn't hide. The destruction moved faster than any living creature could possibly escape. Within the first minute, the explosion had already sent debris beyond Earth's atmosphere. Gigantic pieces of rock were launched into space. Some escaped Earth's gravity forever. Others began falling back. And that was only the beginning. The impact generated shockwaves moving faster than the speed of sound. As they spread across North America, forests were flattened like fields of grass beneath an enormous invisible hammer. Meanwhile, temperatures near the impact rose to levels hotter than the surface of the sun. Rock became vapor. Sand melted into glass. Anything living nearby simply ceased to exist. But perhaps the most terrifying part was that the disaster didn't stay local. It became global. Only a few minutes after impact, the atmosphere itself became part of the catastrophe. Countless fragments of molten rock shot into space before raining back toward Earth. As they re-entered the atmosphere, they heated the air across entire continents. Imagine billions of burning projectiles falling from the sky at once. The heavens themselves appeared to catch fire. Across regions thousands of miles away, animals looked upward as brilliant streaks crossed the sky. No one knew that every glowing fragment carried death. The intense heat ignited dry vegetation almost everywhere the fiery debris landed. Small fires rapidly merged into enormous wildfires. Smoke began rising into the atmosphere long before the largest wave of destruction had even arrived. Yet the dinosaurs still had no idea this was only the opening act. Far from the impact site, many animals probably survived those first few minutes. Some continued grazing. Others kept hunting. The earth beneath them trembled, but few could have understood what it meant. For creatures living thousands of miles away, the danger was still racing toward them, and it was moving incredibly fast. The earthquakes triggered by the collision traveled through Earth's crust across entire continents. In some places, the ground shook violently enough to split open. Lakes sloshed from side to side, cliffs collapsed, ancient forests swayed as though the planet itself had come alive. Then came another nightmare. The impact displaced an enormous volume of seawater. A colossal tsunami began spreading across ancient oceans. Near the impact site, waves may have reached heights greater than many skyscrapers. As these walls of water rushed outward, coastlines vanished beneath them. Everything in their path was swept away. Even places thousands of miles from the impact eventually felt the force of these massive waves. The oceans carried the asteroid's violence across the globe. Meanwhile, the atmosphere continued filling with dust, ash, sulfur, and vaporized rock. At first, sunlight still reached the ground, but with every passing minute, the sky became increasingly hazy. The brightness of day slowly faded behind a growing curtain of debris. Animals that depended on vision became confused. Bird-like dinosaurs took flight through smoky skies. Large herbivores wandered nervously across burning landscapes. Predators that had ruled Earth for millions of years suddenly found themselves in a world they no longer understood. The balance of nature had been shattered in less time than it takes to watch a short video online. And still, the worst was coming, because the first minutes after the impact did not actually kill most dinosaurs. Instead, those minutes triggered a chain reaction that no living creature could stop. A chain reaction that would darken the skies, collapse the food chain, freeze the planet, and erase nearly 75% of all species on Earth. The asteroid delivered the first blow. Nature delivered the rest. In the next part, we'll follow the disaster hour by hour as firestorms spread across continents, the skies turned black, temperatures crashed, and life on Earth entered one of the darkest chapters in its entire history. The first minutes were only the beginning. The asteroid had struck, the shockwaves were racing across the planet, and massive fires had already begun. But now, hour by hour, Earth was transforming into a world almost nothing could survive. As debris continued falling back through the atmosphere, the sky became brighter than many wildfires combined. Billions of pieces of molten rock re-entered the atmosphere at incredible speeds, heating the air over huge portions of the planet. Even regions thousands of miles from the impact experienced an intense pulse of heat. For countless animals, there was nowhere to escape. Forests that had stood for millions of years suddenly burst into flames. Dry vegetation ignited almost instantly, and small fires quickly merged into enormous firestorms. Powerful winds fed the flames, allowing them to spread across entire landscapes. The smoke climbed higher and higher into the atmosphere. Gigantic predators that had once dominated Earth were now fleeing the same fires as the animals they hunted. In a matter of hours, the food chain that had existed for over 160 million years was breaking apart. Near the impact site, the destruction remained almost impossible to imagine. The crater continued collapsing inward while molten rock pooled across the devastated landscape. Earthquakes continued shaking the ground, triggering landslides and causing more destruction far beyond the original impact zone. Meanwhile, the tsunami continued expanding across ancient oceans. As the waves reached distant coastlines, they flooded river valleys, ripped apart forests, and carried enormous amounts of sediment far inland. Entire coastal ecosystems disappeared beneath walls of water. Evidence of these giant waves still exists today, preserved in layers of rock that scientists have discovered around the world. But while fire and water destroyed Earth's surface, an even greater danger was rising into the sky. The impact had blasted unimaginable quantities of dust, ash, soot, and sulfur high into the atmosphere. Unlike ordinary clouds, this material would not disappear after a few days. Instead, it continued spreading around the globe. At first, the changes seemed gradual. The sun became dimmer, shadows became weaker, the sky turned from blue to a strange gray color. Then, as more particles filled the atmosphere, daylight itself began to fade. Within a short time, many regions experienced darkness unlike anything modern humans have ever witnessed. This wasn't an ordinary storm. It wasn't a volcanic eruption. It was a planetary catastrophe. Plants immediately faced a crisis. Without sunlight, photosynthesis slowed dramatically. Leaves that had been producing energy only hours earlier could no longer capture enough sunlight to survive. The collapse had begun at the very bottom of the food chain. Large plant-eating dinosaurs depended on enormous amounts of vegetation every single day. Some species consumed hundreds of pounds of plants daily just to stay alive. Now, fresh vegetation was disappearing. Burned forests could no longer provide food. Darkened skies prevented new growth. The supply of edible plants began shrinking across entire continents. At first, many herbivores probably kept searching for food, unaware that their world had permanently changed. They wandered farther. They competed for fewer resources. As days passed, hunger became impossible to avoid. For predators, the situation became just as desperate. At first, there were still animals to hunt, but injured prey became scarce. Healthy prey became harder to find. Large predators required enormous amounts of energy. Without a constant food supply, even the most powerful hunters slowly weakened. The kings of prehistoric Earth were becoming victims of a disaster they could neither fight nor outrun. Meanwhile, another invisible threat was developing. The enormous amount of sulfur released by the impact mixed with water vapor in the atmosphere. This chemical reaction produced acidic rainfall. When the rain finally returned, it was unlike normal rain. It damaged freshwater ecosystems. It stressed surviving plant life. It added yet another obstacle for animals already struggling to survive. Every part of Earth's environment was changing at the same time. Fire, darkness, starvation, acid rain, earthquakes, tsunamis. No ecosystem remained untouched. Even the oceans were beginning to suffer. Tiny marine organisms called plankton form the foundation of ocean food webs. Like plants on land, many plankton depend on sunlight. As darkness spread across the oceans, plankton populations began collapsing. Small fish lost their primary food source. Larger fish lost theirs. Marine reptiles that had ruled ancient seas for millions of years suddenly faced the same crisis unfolding on land. The extinction was becoming truly global. Yet, despite all this destruction, not everything died. Some small mammals remained hidden inside underground burrows. Certain birds found temporary shelter. Crocodilians rested beneath water where temperatures remained more stable. Turtles, insects, amphibians, and many freshwater organisms proved surprisingly resilient. Their smaller size required less food. Their sheltered habitats protected them from some of the worst conditions. Most importantly, many of them could survive for long periods with limited resources. Ironically, the gigantic size that had once made many dinosaurs so successful now worked against them. Their enormous bodies demanded enormous amounts of food, and that food was disappearing faster every day. Weeks after the impact, the fires slowly began dying down, but the smoke and dust remained trapped high above Earth. Instead of warming the planet, sunlight was now being reflected back into space. Global temperatures began falling. Warm ecosystems that had remained stable for millions of years entered a sudden period of cooling. Seasonal patterns were disrupted. Growing seasons disappeared. Entire habitats changed. Animals that somehow survived the fires now faced freezing conditions they had never evolved to endure. The extinction was no longer caused by one catastrophic event. It had become a series of disasters, each one making survival even less likely than the last. The asteroid itself had struck for only a few seconds, but the consequences continued unfolding day after day, week after week. Each sunrise brought less light. Each passing week brought less food. Each passing month reduced the number of surviving species. Earth had entered one of the darkest periods in its entire history, and in the next part we'll explore how months turned into years, why nearly 75% of all life disappeared, and how a handful of tiny survivors inherited a planet that no longer belonged to the dinosaurs. Months passed after the asteroid struck, but Earth still hadn't recovered. The flames that had once covered entire landscapes gradually faded, yet the greatest threat remained overhead. A thick blanket of dust, ash, and soot continued circling the planet, blocking much of the sunlight that life depended on. The world had become colder. With less sunlight reaching the surface, global temperatures dropped dramatically. Regions that had once been warm year-round experienced conditions unlike anything their ecosystems had evolved to survive. Plants struggled to grow. Forests failed to recover. Rivers and lakes supported less life than before. For the surviving dinosaurs, every day became a battle against starvation. The largest plant eaters had once thrived because Earth provided an endless supply of vegetation. Now they wandered across burned and barren landscapes searching for food that no longer existed. They covered greater distances while consuming less energy than their massive bodies required. Eventually, exhaustion began claiming animals that had survived the initial catastrophe. As herbivores disappeared, predators faced the same fate. Powerful hunters that had once ruled the planet could no longer find enough prey. Hunting became less frequent. Every failed chase wasted precious energy. Injuries that once would have healed now became life-threatening because weakened animals lacked the strength to recover. The ancient food web was collapsing from the bottom up. This wasn't a sudden extinction anymore. It was a slow, relentless collapse. Each week brought fewer plants. Each month brought fewer animals. Entire species quietly disappeared without leaving another generation behind. The silence spreading across Earth would have been unlike anything our planet had experienced for millions of years. Forests that had once echoed with the calls of enormous dinosaurs became strangely quiet. The skies held fewer flying reptiles. The oceans contained fewer giant marine predators. Life itself seemed to be fading. Yet hidden beneath fallen trees, inside burrows, beneath riverbanks, and among dense vegetation, a few remarkable survivors continued to endure. Small mammals became some of the greatest success stories of this catastrophe. Unlike giant dinosaurs, many mammals needed only small amounts of food. They could eat seeds, insects, roots, and almost anything else they could find. Some remained underground for long periods, protected from the harsh conditions above. Being small became a tremendous advantage. Animals that reproduced quickly also gained an important edge. Even if many individuals died, new generations could appear much faster than those of enormous reptiles that took years to mature. Birds also proved surprisingly resilient. Not every bird survived, but the ancestors of modern birds possessed characteristics that improved their chances. Smaller bodies, varied diets, and the ability to travel in search of food helped some populations persist, while countless others vanished. Freshwater ecosystems also became unexpected refuges. Rivers and lakes continued supporting life even as conditions on land deteriorated. Crocodilians survived by spending much of their lives in water, and by slowing their metabolism when food became scarce. Turtles endured because many could survive long periods with little nourishment. Amphibians remained sheltered in moist environments where temperatures changed less dramatically than on open land. Insects survived in astonishing numbers. Some fed on dead organic matter. Others lived underground. Many reproduced rapidly, allowing their populations to recover far more easily than those of larger animals. The survivors shared one important trait: flexibility. They didn't rely on a single food source. They didn't require enormous amounts of energy, and many could adapt to rapidly changing environments. The giant dinosaurs simply couldn't. As years passed, the skies slowly began clearing. Dust particles gradually settled back to Earth. For the first time since the impact, sunlight once again reached the surface in greater amounts. But the world the sunlight revealed was almost unrecognizable. Entire forests had disappeared. Countless species no longer existed. The ecosystems that eventually began recovering looked very different from those that had existed before the asteroid struck. Scientists estimate that around 75% of all species on Earth became extinct during this event. Every non-avian dinosaur vanished. The giant marine reptiles disappeared. Flying reptiles that had ruled prehistoric skies for millions of years also came to an end. It marked the close of one of the most extraordinary chapters in Earth's history. But every ending creates the possibility of a new beginning. With the dinosaurs gone, ecological niches that had remained occupied for over 160 million years suddenly became empty. There were fewer giant predators, fewer massive herbivores, less competition for food and territory. The surviving mammals entered a world filled with opportunities that had never existed before. Over millions of years, they began evolving into new forms. Some adapted to climbing trees, others returned to the oceans. Some became fast runners across open plains. Others developed sharper vision, stronger hearing, and more advanced brains. Slowly, almost unnoticed at first, mammals expanded across the planet. The asteroid had not chosen mammals as winners. It had simply removed the dominant rulers of Earth. Evolution did the rest. One tiny survivor after another gradually transformed the future of life. If the asteroid had missed Earth entirely, dinosaurs might have continued dominating the planet for millions more years. Large mammals may never have evolved into their modern diversity. Primates might never have appeared, and without primates, humans may never have existed. Everything about our own story depends on that single impact that lasted only seconds. One ordinary day became the turning point for every living creature that came afterward. The age of dinosaurs ended. The age of mammals quietly began. But one final mystery remains. How do scientists know so much about an event that happened 66 million years ago? In the final part, we'll uncover the remarkable evidence buried beneath Earth's surface, the discoveries that revealed exactly what happened on that catastrophic day, and why this ancient impact still serves as a warning for the future of our own planet. For centuries, the disappearance of the dinosaurs remained one of the greatest mysteries in science. Their fossils were discovered on every continent, proving they had once dominated the planet. Yet no one could explain how creatures so successful had vanished so completely. The answer was hidden beneath Earth's surface for millions of years. In the late 20th century, scientists made a remarkable discovery. Around the world, they found a thin layer of rock dating to exactly the time the dinosaurs disappeared. This layer contained unusually high amounts of iridium, an element that is rare in Earth's crust, but far more common in asteroids. The same chemical signature appeared in locations separated by thousands of miles. It was the first major clue that something from space had changed Earth's history. As researchers continued investigating, even more evidence emerged. They discovered tiny glass beads formed when rock was instantly melted and blasted into the atmosphere before cooling back into solid particles. They found shocked quartz, a unique form of mineral created only under enormous pressure, such as a nuclear explosion or an asteroid impact. They uncovered ancient tsunami deposits far inland, proving that gigantic waves had swept across coastlines. Every new discovery pointed toward the same conclusion. An asteroid had struck Earth with unimaginable force. Then came one of the most important discoveries of all. Buried beneath the Yucatan Peninsula in Mexico was an enormous circular structure stretching nearly 120 miles across. It was the scar left by the impact itself. Today, scientists know it as the Chicxulub crater. Although much of it is hidden beneath layers of rock and sediment, advanced imaging has revealed its unmistakable shape. The crater perfectly matches the age of the extinction. It matches the chemical evidence, it matches the geological evidence, and it matches computer simulations of an impact powerful enough to trigger a global catastrophe. Together, these discoveries solved one of Earth's greatest mysteries. But scientists didn't stop there. Using advanced computer models, they recreated the impact in extraordinary detail. They calculated the asteroid's speed, its size, its angle of impact, the amount of energy it released, the height of the tsunamis, the spread of the firestorms, the cooling that followed. Again and again, the evidence led to the same story. The extinction was not caused by a single explosion. It was caused by a chain reaction. The impact triggered earthquakes. The earthquakes were followed by tsunamis. Molten debris ignited global wildfires. Dust and soot blocked sunlight. Photosynthesis collapsed, food chains failed, temperatures dropped, starvation spread across land and sea. Each disaster made the next one even worse. It became one of the most devastating sequences of events our planet has ever experienced. Yet despite losing roughly 75% of all species, life itself did not disappear. It adapted. It recovered. Over millions of years, forests returned, oceans stabilized, new ecosystems emerged. The survivors evolved into forms that would eventually shape the modern world. Every elephant, every whale, every eagle, every wolf, every human being. Our existence is connected to the events of that single day. If the asteroid had arrived a few minutes earlier or later, it would have struck a different part of Earth. The consequences might have been dramatically different. The extinction may have been less severe, or it could have been even worse. The exact timing and location changed the course of evolution forever. Even today, Earth continues traveling through a solar system filled with asteroids and comets. Fortunately, impacts on the scale of the Chicxulub event are extremely rare. Modern astronomers continuously monitor the skies, tracking near-Earth objects and identifying potential hazards decades before they come close to our planet. Space agencies are also developing technologies designed to alter the paths of dangerous asteroids if one were ever found on a collision course with Earth. Unlike the dinosaurs, humanity has something they never had: knowledge. We understand the danger. We know where to look. And for the first time in Earth's history, one species has the ability to prepare for a threat arriving from deep space. Still, the story of the dinosaurs remains a powerful reminder of how quickly life can change. For more than 160 million years, dinosaurs dominated the Earth. They survived changing climates, shifting continents, Volcanic eruptions, rising and falling seas, they seemed unstoppable. Yet one object from space erased their reign in what was, geologically speaking, the blink of an eye. Nature doesn't recognize the strongest. It doesn't guarantee survival to the largest. Instead, history repeatedly shows that survival belongs to those capable of adapting when the world changes. That lesson has echoed across 66 million years. The first minutes after the asteroid struck did far more than end the age of the dinosaurs. They reshaped the future of every living thing that followed. Without that single impact, mammals may never have flourished. Without mammals flourishing, human beings may never have evolved. In a very real sense, our own story began on the day theirs ended. The next time you look at the night sky, remember that the same universe that gave birth to our planet also delivered the object that changed it forever. One ordinary day became the most extraordinary turning point in the history of life on Earth. And the echoes of those first terrifying minutes are still with us today.